Dear viewers, welcome to the YouTube channel H2O Chemistry. So in our channel we have been watching the videos which are related to chemistry topics, and we teach chemistry with the reasons. That's our specialty of the channel. So if you like this video, subscribe and click the bell button to get the notification immediately. My dear children, in this video we are going to talk about the comparison of properties of metals and non-metals. The speciality of this video is we are going to talk about the exceptions alone. So the first property we will see, the property is physical state. We know that metals are solids. Mostly the metals are solids. Very few metals available in liquid state. So we know very well that mercury is in liquid state at room temperature. So you could see the mercury is a liquid at room temperature, whereas the other metals like cesium, rubidium, francium and gallium, you could see the cesium is slowly converted into liquids above the room temperature. So if the temperature rises above 28 to 35, so within that range the cesium will liquefy. Similarly, the rubidium, francium and gallium, you know very well about this. The gallium, even if you hold it, a solid gallium, if you hold at hands, by absorbing your body temperature, it melts. You could see the picture here clearly. Now similarly, the other metals like rubidium, francium, all will melt just above the room temperature. That means they have a low melting point. Come to the non-metals. Non-metals are generally solids, liquids and gas at normal temperature. The only one non-metal available in liquid state is nothing but bromine. You could see here the bromine is converting into liquid and then it vaporizes. So these are the exceptions we have to learn clearly. Next one, hardness. The property of next one is hardness. So metals are usually hard. Yeah, definitely yes, because if you want to break it, we cannot break it easily, right? But there are some exceptions. The exception here is sodium and potassium. Sodium and potassium you can easily cut with knife. You could see the picture here. The sodium can be cut easily with a knife. Even potassium you can easily cut with a knife. So that indicates they are soft. They are soft. Unlike other metals, they are very, very soft. Now, and the one more interesting information, these two metals are kept under corrosion because then sodium and potassium are violently react with moisture. So do we have a moisture in our air? Yes. So when you keep outside, these metals, the sodium and potassium, they absorb moisture and they explode, or they react with the moisture and they catch fire. So in order to avoid that, so we used to keep the sodium and potassium under corrosion. So additionally you learn this. And then the next one, the osmium. Osmium you could see so hard that can scratch glass. Very important. See, one of the experiments shows that the osmium is more harder than harder than diamond. So it means it has more hardness, so we can use instead of diamond. So it's very hard even when compared to diamond. So now compared to the non-metals. So non-metals, out of the non-metals, all are soft, but exception is diamond. We know diamond, cut diamond, that means very, very hard. So Mohs scale, it is one of the hardness scale we call. From this, if you measure, a diamond takes the toppest rank, that is 10. That means it's a very hard substance out of these 10. So this is an important one. So diamond is so hard to break. Now come to the third property, that is luster. What is meant by luster? Luster means when you expose the substance to the light, the surface will shine. So shininess is called luster. So all the metals are shining, but exception is calcium. You could see the calcium It's not very shiny, so we could see it's can I call it's a less luscious, I can call. So calcium is less luscious. Then compared to the next one, non-metals. Non-metals generally have a dull look. Dull look. That means they are not very shiny when exposed to light. Whereas the graphite and iodine, this graphite is a very shiny. You could see in this picture when exposed to light. Why does this happen? The reason behind this is every graphite is made up of carbon. So in the carbon, each carbon in graphite has free electron. This point you have to be very clear. Free electrons. This free electrons will roam here and there in a graphite. So that makes this whole thing shiny. Now come to the iodine part. Iodine is also very shiny. You could see the surface. So this is because the electrons are further away from the nucleus, because the size of the iodine is very bigger. So the electrons are I can say less controlled by the nucleus. So for that reason, so it can jump from one atom to another atom. So that this creates shininess for iodine. Okay, anyway, these are the very simple explanation I have given to you regarding this graphite and iodine, but still you'll be finding more in your higher studies. Now let us go to the next topic, that is density. Now metals usually have a high density. Here when you lift it, you could see the heaviness. That means if the mass is higher, density will be higher. So the number of atoms packed per unit space is more in the case of metals. That's why the density is more. Whereas some of the metals are exceptions. You could see sodium and potassium. I told you can cut with knife, which indicates they are very soft. That means they are less dense. They are less dense. Come to the next one, that is non-metals. Non-metals generally have low density. Yes, absolutely yes, because most of them are gases like oxygen, nitrogen, hydrogen, chlorine, fluorine. So usually gases have a low density. So that's why the reason we call non-metals have a less density we call. But exception is diamond. It's so hard, and it's very rigid, and they have a high density too. So it's an exception. Now come to the next property, that is a melting and boiling point. So metals usually have a high melting and boiling point, but in our first video we have seen that some metals will melt just above the room temperature. The examples are mercury, gallium, cesium, rubidium, francium are the exceptions. So if you look at the mercury, the melting point you just watch here, it's very important. Minus 38.9 degrees centigrade. So which indicates it's very low melting point it is. Even the boiling point is comparatively low, 356.7 when you compare to other metals. Come to the gallium, 29.7, and the boiling point is 2400 degrees centigrade. Similarly, cesium, francium, rubidium will just melt above the room temperature, so their melting point is low. Come to the next category, that is non-metal. Non-metal have low melting and boiling point. But there are some exceptions. Carbon, silicon, boron are the exceptions. Carbon in the form of diamond. If you look at the diamond, it melts around 3550 degrees centigrade and boils around. So when you keep on heat it, the interparticle force of attraction breaks, and then it started to boil, and that is what we call boiling point. So in that state, the liquid diamond or liquid carbon will convert it into gaseous carbon state. Now similarly, boron have a very high melting and boiling point. You could see the figure here. And silicon, similarly, they have a high melting and boiling point. So these are the exceptions which I have given in the data. Now next property is tensile strength. Now what do you mean by tensile strength? The tensile strength is nothing but an object, it holds some weight. So up to certain weight it can hold, right? Or we can say some kind of some kind of weight it can hold. So when you make a thread, if you hold a 10 kg of any stone or something, if it holds that, the tensile strength of that thread is 10 kg. So when you make it to 11, the thread cuts automatically, means we can say that the tensile strength is maximum of 10 kg. That's all. So we talk about metals here. Metal usually have a high density. You could see the uh, uh, bridge making process. In this, most of the concrete blocks, very heavy concrete blocks, are lifted by chains which are made up of metals. So that means they have a high tensile strength. Now there are some exceptions. Now we will see that zinc, arsenic, antimony are the exceptions. Look at this figure which I have taken from the net, Google. Now zinc, it has a very less 37 megapascal, so that has a very less tensile strength. Compared with iron, it has a 540, right? So compare the other arsenic and antimony, 17.2 and 11.4. So when compared to iron, they are very less. That's the reason we call it as an exception. Now come to the non-metal, do not have a high tensile strength. That means they have a less than tensile strength, but exception is carbon fiber. Look at this. The steel, this is a 951 megapascal, but we compare to carbon fiber, it is 228 gigapascal. So it's higher than mega. It's higher than mega. So this is a thing we have to understand. Now we will see the next property. The next property is conductivity. So look at this. Metals are usually very good conductor of heat and electricity. We know that we use copper wires, aluminum wires, all are very good conductors. So we use it for our home purpose to take a line from the post, right, electrical post. So we know very well that the copper wire is mainly used for the household purposes. Now there are some exceptions. Some metals like bismuth, tungstens are bad conductors. Example, see, I couldn't find any picture regarding this, but I could see some informations about this bismuth. The bismuth is a poor conductor of electricity and heat. Scientists says it has a very poor electrical and thermal conductivities. It is relatively stable, does not corrode in the atmosphere unless attacked by strong acids. So bismuth can attack by strong acids like hydrochloric acid, nitric acid, sulfuric acid, but the other things, no, does not corrode, so it doesn't form rust like iron, right? Now, so it's a bad conductor. Now come to the next one, the tungsten. Tungsten we use in the bulb, right? It's a small filament. But why this tungsten is used in electrical bulbs? Although it's a poor conductor, so it's a poor conductor, but it's still used in the what? Bulbs, which indicates it's a poor conductor. It's tolerant of high temperature. Remember, so when keep on pass a current to particular object, it heats up, right? So in order to avoid breakages, we use tungsten. It's a less conductivity and it's high tolerance to temperature. The filament of the light bulb was very good conductor. The circuit will break or fuse. That is the reason we use like a poor conductor like tungstens in the electrical bulb. Now, generally non-metals are bad conductor of heat and electricity, but a graphite is a very good conductor, because I told you in graphite each carbon has a free electron. So the free electron can jump from one carbon atom to another carbon atom, which makes the graphite good conductor. You could see the picture here. The graphite present in the pencil conducts electricity. Now come back to the next one, that is the last property we're going to talk about, that is malleability. What do you mean by malleability? The metals can be drawn into sheets by beating. There is no exceptions here, but the gold is highly malleable. This information you should know. Similarly, non-metals are non-malleable. so we cannot make into sheets. But exception is carbon fiber, I can say, because you could see the carbon fiber sheets here. Similarly, ductility. What do you mean by ductility? We can drawn into thin wires. That property is called ductility. Metals are usually ductile, so we can make into wires. Similarly, non-metals are non-ductile, but non-ductile means we cannot make into thin wires. But carbon fiber is an exception. So the carbon fiber only they made the sheet. So it's a ductile property it has. Similarly, sonorous. So what is meant by sonorous? When you hit two metal plates, we could hear some sound like cling sound. So this is a property of metals. So when you dash metals, they produce sound, a characteristic sound. So that property we call sonorous. So this property makes the objects like bell, right, gongs, so that creates sound. Even you could see in temples. So this is a very important property of metal. So sonorous property of metal makes things like bells. Remember. Next, the non-metals are non-sonorous. That means they do not produce any sound. But exception, I can say iodine. Some no, when you just shake iodine bottle, so the beads in the iodine will create a cling sound like metals. So its exception is iodine here. But anyway, it's not mentioned. But you should know this. Now, I hope this video is very helpful in learning this properties of metal, especially the exceptions alone. Thank you so much. We will see in our next video with the interesting facts like this. Thank you so much for watching.